Hello, let my presentation to load, it takes time. But today we started to talk about concept called mole, and sometimes it causes some frustration or misunderstandings, so let's talk about it a little bit more. The word mole is not scary at all, it's just a word that means a specific number. Well, for example, the word dozen never scares you, right? The moment you hear the word dozen, you think about this number. Dozen means 12. Dozen of eggs, dozen of apples. That doesn't sound too bad, right? So the same can be said about the word mole. When we use it in chemistry, we mean a specific number. Well, very large number to be admitted, but here is the number. When we say mole, we mean 6.02 times to the 10 to the power of 23 of something, of atoms, molecules, ions. So let's see how it works. When we say 1 mole of aluminum, we mean this number of atoms of aluminum. When we say 1 mole of sodium, we mean 6.02 times to the 10 to the power of 23 atoms of sodium. When we say 1 mole of water, we mean this number of molecules of water taken together. So let's imagine that inside of this glass I have 1 mole of water. What it means? It means that this entire body of water is made up by 6.02 times to the 10 to the power 23 units like this. I have that number of water molecules stuck together inside of this glass. So far so good. But here's something that sometimes students find difficult to picture, to imagine. 1 mole of water is made out of oxygen and hydrogen. Each oxygen connected through the covalent bond with 2 hydrogen atoms. And if we have 1 mole of water, that means that we have this number of molecules like this inside of our glass for the current purpose. So let's imagine that we decided to count all the oxygens that happen to be there. We go around counting 1, 2, 3, 4, 5, and so on until we count every single oxygen that happened to be inside of the glass. Well, considering that we have that many molecules and each of them has 1 oxygen inside of it, we will end up having that many atoms of oxygen inside of it. And we agreed that this specific number has a name. We call it a mole. That means that inside of 1 mole of water there is a mole of atoms of oxygen. Well, now let's imagine that we decided to count all the hydrogens. We'll go around 1, 2, 3, 4, 5, and so on. Considering that each oxygen carries 2 hydrogens, we will end up with twice this number of hydrogens. That will be 12.04 times to the 10 to the power of 23 atoms of hydrogen. And since it's twice that special number that we call mole, we can say that it is 2 moles. 2 moles of atoms of hydrogen. This is why we can say that inside 1 mole of water there is 1 mole of oxygen atoms and there are 2 moles of hydrogen atoms. And this is the trouble that is usually students find difficult to wrap their heads around. 2 moles of atoms of hydrogen and 1 mole of atoms of oxygen create 1 mole of water. Let's see some other example that maybe will clarify how it happens. Well, here I have 12 Lego ladies. Well, since there are 12 of them, I can call them a dozen, right? A dozen of Lego ladies, 12 Lego ladies. They made of, I count all the parts that went into making 12 dozen Lego ladies, I would say that I would need 12 heads, 1 dozen of heads, 1 dozen of bodies, 2 dozen of legs, and 2 dozens of hands. So all these dozens of legs, hands, bodies do not create 6 dozens of ladies. They create only 1 dozen of them. The same can be said about our oxygen, about our water example. If we had that many full molecules of water, all of them, one mole of these water molecules made out of 1 mole of atoms of oxygen and 2 moles of atoms of hydrogen. This is why we can say that 1 mole of water made out of 1 mole of atoms of oxygen and 2 moles of atoms of hydrogen. Okay, so let's look at this example. Now we are talking about 1 mole of ammonia, NH3, the gas. And since we have 1 mole of this gas, it means that we have that many molecules of NH3, molecules like this, in some kind of container, because ammonia is a gas at room temperature. Okay, so if we go around counting all the nitrogens that are inside of that container, that are carrying those hydrogens in them, well, we will end up having that many numbers of nitrogen counted as a result of it. And since we agreed that this particular number has a specific name, we can say, well, 1 mole of atoms of nitrogen that we have inside of this container, inside of this mole of ammonia. If we go around counting all the hydrogens that happen to be there, knowing that each and every molecule carries 3 of the hydrogens, we will end up having 18.06 times to the 10 to the power of 23 atoms of hydrogen, which is 3 times that specific mole number. So instead of writing this big and bulky number, we can say that we have 3 moles of atoms of hydrogen. And we can say that 1 mole of ammonia made up by 1 mole of atoms of nitrogen and 3 moles of atoms of hydrogen. I hope it helped.